Hello friends, I am Karthik, Assistant Professor of Physics at the Majuro College, Madurai. In this video, I am going to talk about motion of a body in a straight line or motion of a body in one dimension. First of all, we need to understand the difference between rest position and motion. If an object continues to remain in the same state with respect to its surroundings over a period of time, in other words, if the position of an object does not change with respect to its surroundings over a period of time, then it is said to be in rest position. If the position of an object continuously changes with respect to its surroundings over a period of time, then it is said to be in motion. Then the next question is how to locate the position of an object and how can we know about the position of an object. For that we need a frame of reference. This three-dimensional coordinate system or a rectangular coordinate system is the best example for a frame of reference. Here there are x, y and z axes. These three axes can be used to describe the position of an object. If the object moves in a three-dimensional space, we need all the three coordinates to locate its position. If the object moves only in two dimensions, we can use just two of the coordinates to define the position. If the object moves only in one dimension or if the motion of the object is confined just to one dimension, we can just use either of all the three coordinates, either any one of all the three coordinates to locate the position. So motion in a straight line or one dimension means the motion of the object is confined in only one dimension. A best example for this is the motion of a beads in an abacus. In an abacus, the beads move only along the frame of the abacus. So its motion is the best example for motion in a straight line or motion in one dimension. The next thing is we need to know about the concept of distance and displacement. What is the difference between distance and displacement, which is all we have to know in order to understand this concept well. Distance is nothing but the total path traveled by a body during its motion, and the displacement is the shortest distance connecting between the 2 points. For example, A and B are 2 points. If the object travels like this and finally it reaches B, what is the total path traveled by this object while coming from A to B is called the distance. The shortest distance connecting between these 2 points is called displacement. The another major difference between distance and displacement is that distance is a scalar quantity and displacement is a vector quantity. So what is meant by scalar and vector quantity? Scalar quantity is the one which has magnitude only, and the vector quantity is the one which has both magnitude and direction. As far as distance is concerned, you are concerned mainly about the magnitude only, that is the total path traveled by the body while going from one place to another place or one point to another point. But as far as vector is concerned, we need to mention in what direction it is traveling. For example, once again I take this example, A, here B. These 2 points are, for example, 40 meters apart. If an object starts here and it reaches B and then it comes once again to A, it has traveled a distance of 80 meters in total. I hope you are getting me. I am going to repeat it again. The object has started from A and it has reached B, and then again it has traveled from B and it has reached A. Overall, it has traveled a distance of 80 meters in total. But what is the displacement of the body? Since it has started from A to B, it has traveled in one direction. On going from B to A, it has traveled in exactly opposite direction, but the same distance 40 meters. That means, since the object has traveled 40 meters and another 40 meters in the opposite direction, its displacement is 0. Why it is 0? because here we have taken both the magnitude and direction into account as far as displacement is concerned. As far as distance is concerned, we concentrate only on the total path. On the whole, the object has traveled 80 meter, that is its distance, but the object's displacement is just 0. I hope you have understood what is the difference between distance and displacement. I can give you another example also in order to make it clear. Let us say an object starts from here at this point A. It travels 4 meter in the east direction. From B, it travels 3 meter. Finally, it reaches C. What is the distance traveled by this body? It is totally 4 plus 3, 7 meter. What is the displacement of this body? It is the distance AC, which comes around 5 meter, which is exactly 5 meter. Because here we have taken the direction also into account. So here the total distance travelled is 4 meter plus 3 meter equal to 7 meter. The displacement AC is just 5 meter, which we can calculate using the Pythagoras theorem. This is the difference between distance and displacement. So the main difference is we are incorporating the direction while talking about the displacement. Okay, we have seen the difference between distance and displacement. Now we are going to see what is the difference between speed and velocity. As we have discussed earlier, speed pause here. Earlier we have discussed the difference between distance and displacement. Now we are going to discuss the difference between speed and velocity. Speed is actually the rate of change of distance. Velocity means the rate of change of displacement. Here we are concerned with distance while talking about speed, and velocity means the rate of change of displacement. The major difference here is speed is a scalar quantity and velocity is a vector quantity, because speed involves the rate of change of distance, which is a scalar, and velocity involves the rate of change of displacement, which is a vector quantity. Here is the formula for speed. So distance by time taken and displacement by time taken gives you the velocity. As I have mentioned earlier, speed is a scalar quantity and velocity is a vector quantity. Now we are going to see what is meant by uniform velocity or uniform speed. There are differences between uniform and non-uniform speed, or uniform and non-uniform velocity. Uniform speed. Uniform speed means if the object covers equal distances in equal interval of time, then the object is said to be moving with uniform speed. If the object covers unequal distances in equal intervals of time, then it is said to be moving with non-uniform speed. Similarly, if an object moves, or if the object covers equal displacements in equal interval of time, then it is called uniform velocity. So uniform speed means equal distance in equal interval of time. Uniform velocity means the object covers equal displacements Uniform speed. Uniform speed means the object covers equal distance in equal intervals of time. Uniform velocity means the object covers equal displacements in equal intervals of time. Non-uniform speed means the object covers unequal distance in equal intervals of time, and non-uniform velocity means the object covers unequal displacements in equal intervals of time. So these are the major concepts which we need to know in order to understand motion in a straight line or motion in one dimension. If the object has uniform speed, then the formula involves total distance divided by time taken So here there is no problem with speed because the speed of the body is uniform. It covers equal distances in equal intervals of time. So you don't have to worry about anything else. You just substitute the formula total distance by time taken and then you can calculate the uniform speed. But if the body moves with non-uniform speed, that means if the distance covered by the body is s1 in t interval of time and s2 in t2 interval of time and s3, if the body covers s1 distance in t1 amount of time, s2 distance in t2 amount of time, s3 distance in t3 amount of time. So we have to use this formula in order to calculate its non-uniform speed. So for non-uniform speed, the object covers unequal distances in equal intervals of time. So if the body covers s1 distance in t1 amount of time, s2 distance in t2 amount of time, s3 distance in t3 amount of time, we need to use this formula in order to calculate the non-uniform speed. Same concepts apply for uniform and non-uniform velocity also. If the velocity of the body is uniform, you have to just substitute the formula total displacement by time, that is uniform velocity equal to total displacement by time On the other hand, if the body moves with non-uniform velocity, that means if the body has or if the body covers d1 displacement in t1 amount of time, d2 displacement in t2 amount of time, d3 displacement in t3 amount of time, you need to use this kind of formula because the displacement is different for different intervals of time. We have to use this formula in order to calculate the non-uniform velocity of a body. This is all about uniform and non-uniform speed and velocities. These are the main formula which we have to know in order to tackle the problems in this topic, that is the motion in a straight line. And the other topics which I have to explain here is the differential formula for velocity and acceleration, and one more thing is we need to know about the acceleration. So what is meant by acceleration? Acceleration is equal to change in velocity by time taken. So acceleration means the rate of change of velocity. As in case of uniform and non-uniform velocities, here if the object has same velocity over a period of time, then it is said to be moving with uniform acceleration. The velocity of the body is different in different intervals of time, then we have to call it as non-uniform acceleration. This is all about motion in a straight line, and we need to know about the differential formula for velocity acceleration. So for velocity, this is the differential formula, ds by dt, where ds refers to the change in displacement and dt refers to the change in time. For acceleration, we have to use this formula, a equal to dv by dt, where dv means the change in velocity and dt means the change in time. If you have to calculate the displacement from this formula, you have to transform this equation like this, ds equal to v dt, and then you can integrate this term in order to calculate the total displacement. Similarly, if you have to calculate velocity from this formula, you have to transform the equation like this, and then you have to apply the integration in order to calculate the velocity. This is all about motion in a straight line or motion in one dimension. Here there are no too much of complications when compared to motion in 2 or 3 dimension, because here we are talking only about the motion of a body in only one dimension. So this is all we need to know about this topic. So I am going to summarize whatever I have given in this video. Initially we started with the definition for motion, and then we talked about the difference between distance and displacement, and then speed and velocity, and then uniform and non-uniform velocities, and we have concluded this video with acceleration, which means change in velocity by time taken. So this is all we need to know about this topic. If you like this video, please hit the like button. If you want more videos, if you want to see more videos like this, please do subscribe to my channel. If you want to receive notifications regarding the new videos, please touch the bell icon. And thank you very much. See you again in my next video. Thank you.